So yesterday, yes, the Java introduction, yes, Java complete Java contents, yes, C and interpretation and all that things were discussed. Okay, yes. So first here, that introduction, yes. So first let us start with Java features. Java features. Let us start with Java features. Yes, main features of Java. So main features. Yes, main features of Java. Let's start with main features of Java. Main features. Here they are the main features. Independent platform, portability, groups language, scalability, and security. They are the main features. See, initially Java released with these main features. Initially Java released with these main features. Initially Java released with these main features. First, let us see one by one here. What is independent platform, portability, groups language, scalability, and security. Let us see all these features one by one. See here, independent platform, portability, groups language. To understand these features here, you need some basic concepts. Yes, you must have some basic concepts, idea of basic concepts, like about OS. Yes, about operating system, you must have about operating system knowledge, about operating system. Okay. Next about exe file. Next about dot class file, Java dot class file, Java dot class file. Next about interpreter. Yes, interpreter. Yes, next about compiler. You must have this knowledge here. So first of all, yes, about operating system. Yes, about exe file, about dot class file, about interpreter. Next compiler. Okay. Next generation of languages. Generation of language. Generation of language. So first of all, you must have this idea here. Just to understand, independent platform. Platform means it's a OS. Platform means OS. Okay. So what is OS? How OS is working? That OS knowledge. Next, exe file and dot class files knowledge also must have this. To understand independent platform portability here, how OS is working. Independent platform means independent of OS. That means how OS is working, that OS knowledge. Okay. Next, yes, exe file dot class file, that comparison, that idea. Yes, difference between exe file dot class, that idea here. Okay, right? Next, interpreter compiler. Yes, Java depending on what easy to interpreter compiler, that knowledge. If you have this knowledge, then easy to understand first two features. Next, to understand loop language, this knowledge, generation of language. So first of all, let us start with all of these things. Let us start all of these things here. Okay. Yes. I'm starting with basics. To understand this, first of all, here I'm starting with basics here. Basics. Okay. Yes. Even non-IT background guy also can understand. Non-IT background guys also understand these basics here. Okay. I'm starting from very basics. I'm starting from very basics here. See, computer ware. Yes, computer ware. Computer ware. Yes, very basics, starting from very basics. Finally, I will take to high end. So by the time of finishing course, you can put up minimum 3 to 4 years of experience. That level, I can train you. So first of all, starting basics here. Starting basics. Computer ware. Basically, yes, two things here, two categories. Yes, hardware, and next one, software. Hardware and software. Hardware and software. Hardware and software. Hardware and software. Okay. Basically, two categories. First one, hardware. Next one is software. Hardware and software. So what is hardware? What is software? Okay. Yes. Yes, hardware and software. So hardware, these are physical components of a computer. So hardware means they are physical components like keyboards, mouse, monitor, all these hardware components here. We can touch all these parts, but this is not our part. Our part is software. We are software engineers. We are the software engineers. So our part is software. So let us start with software here. Let us start with software. Let us start with software. Okay. So what is software? Yes, in software, yes, everything is a program. Yes, everything is a program. Everything is a program. Software, everything is a program. In software, everything is a program. In software, everything is a program. Yes, it's a collection of programs. It's a collection. Yes, it's a collection of programs. It's a collection of programs. It's a collection of programs. Collection of programs like C, yes, maybe C++, yes, Java, yes, maybe Python. So like this different kind of programs here. It's a collection of programs. Software. In software, everything is a program. In software, everything is a program. It's a collection of programs. It's a collection of programs. Okay. Yes, here this software basically two categories. Software basically here basically two categories. Two categories. Basically two categories. Basically two categories. Basically two categories. Software basically two categories. Software basically two categories. Two categories. First one, yes, software. System software. Second one, application software. Second one, application software. System software. Next, application software. Okay. Software basically two categories. Software basically two categories. First one, system software. Next one, application software. System software, application software. So what is system software? System software. System software. Yes, system software. This one interacts with the hardware components. System software. This one interacts. Yes, interacts with the hardware components. Interacts with hardware components. Interacts with the hardware components. Okay, system software. System software. This one interacts with hardware components. This one interacts with hardware components. System software. This one interacts with hardware components. Yes, example. Yes, OS, operating systems. Yes, all the operating systems comes on this category. Operating systems, operating systems under device drivers. Operating systems and device drivers. Device drivers comes on this category here. Okay, so OS and device drivers. Next, Java comes on application software. Java is application software. System software. This one interacts with hardware components. Example, operating systems and device drivers comes on this category here. Next, application software. So what is application software here? Application software. This is for the purpose of application development. For the purpose. For the purpose of application. For the purpose of application development. For the purpose of application development. So for the purpose of application development. Okay. Application software. Application software. This is for the purpose of application development. Application development. Apps. Yeah, there are different apps in our daily life. In our daily life, we are using different applications. Can you tell me some examples of applications? What are the applications we are using? Yes, guys. Hello. What are the different applications we are using in our daily life? Yes, there are different applications we are using in our daily life. Our day-to-day life, many applications. Yes, come on. Yes, daily life applications. Simple question, guys. Hello. No answer? Yes. Daily life applications. Can you hear me? Hello. Can you hear me? Hello. Can you hear me? Yes, no one responding. Hello. Can you hear me? Hello.
Sir, yes, sir, we are able to hear you.
Yeah. Thank you. So applications. Yes, Facebook it's application, right? Now tell me. An example
Facebook,
is Facebook. Yes, WhatsApp it's application. WhatsApp it's an application. WhatsApp, Twitter. Okay, there are all the applications. Flipkart, Flipkart. So these are the applications here. Websites. Yes, company websites. Okay, all the applications here. Okay. Yes, online services or e-commerce application, all the applications. Yes, to develop this kind of applications, we need some software. To develop this kind of applications, we need some software. Those are called as application softwares. This kind of applications, Facebook, WhatsApp, Twitter, Flipkart, some websites, next online services, online delivery services here, okay, delivery apps, okay, even go to training app also, go to training, go to meeting, Zoom meeting, all the applications here, all the applications. Yes, to develop these applications, we need some softwares. Those are called as application softwares. Those are called as application softwares. Okay. Yes, application softwares examples. Best example Java. Java is a mostly used application software. Java is a mostly used application software. Java, C is the application software. C++ application software. Support database. Database also application software. Okay. Suppose Hadoop. Hadoop also application software. Python. Python also application software. HTML also application software. Next, SAP also application softwares. Like this, many application softwares. Okay. C in softwares, general languages. There are some languages. Languages. Next, there are some tools. There are some packages. Packages. Languages. Java is a language. C is a language. C++ language. Python language. HTML language. PHP. Perl scripting. Like this HTML. Many languages are there. Next, when come to tools, yes, different tools like warehousing tools, like Informatica, BA tools, testing tools like QTP, Selenium, like this. Next, reporting tools like ClickView, Tableau. Next, AWS tools, DevOps, infrastructure management tools. Next, Hadoop tools, like this, various kind of tools here. Next, packages. SAP, it's a package. ERP packages. SAP, Tally ERP package. Next, Oracle ERP, some packages. All these are application softwares. Simple here. Simple. Yes, except. See, except operating systems. Except operating systems. Except operating systems. All are application softwares. Except operating systems, all are application softwares. All are application softwares. All are application softwares. Okay, all are application softwares. Except OS. Simple here. Except OS. OS is system software. OS is a, we are using many things, right? We are using many softwares in the, yes, is in our life, right? Okay. So except OS. Except OS. Except operating systems. Operating systems like Windows is a OS. Windows, Linux, Unix. These are operating systems. Except these operating systems, except these all are application softwares. Except this, all are application softwares. Simple, simple here. So here, except ways, all are application softwares. That's it. So Java comes under application software. So our part is application software. Our part is application software. Okay. Yes. Before going to application software, let us see something about OS. Yes, OS knowledge. To understand independent platform, you must have OS knowledge. Some OS idea about OS. Okay. Let us see something about OS here. What is OS here? About OS. Okay. Yes, about OS. Yes, to understand about OS here. Yes. Let us see something about OS here. Operating system. Operating systems. Okay. Yes, here some question for you guys. Some question. Here some question. Yes, can we run any program without voice? Without voice. Simple question. Can we run any program without voice? Simple question. Can we run any program without voice? Say yes or no. Can we run any program without voice? Say yes or no.
No, sir.
Yes. Okay, fine. Next, any others? Ping in chat box. Here, chat box is available. Your answers you can ping in chat box. Okay, if unable to speak it, if unable to speak, you can ping in chat box. Chat box is available. In chat box, you can ping it. You can ping it. In chat box, you can share your answer. Okay. Yes. Can we run any program without voice? Answer is no. No. Voice required compulsory. Without voice, we can't run any programs. So compulsory voice required. So what is operating system? So what is voice here? Let us see. So what is, yes, what is operating system? So what is operating system? Let us see about voice here. Yes, to understand independent of platform, let us see about voice. What is voice here? So what is voice? Suppose, for example, your laptop. For example, you purchased your laptop hardware, 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 right? See, when you purchase laptop here, that laptop vendor, yes, they will set up OS and they will give us, right? They'll set up OS. So here on top of hardware, OS setup. Yes, OS setup, operating system. Yes, operating system. Operating system, right? So once OS setup is done, your system is ready. System is ready. This is OS. It's a OS. My system is Windows 10 OS. Windows 10 OS, right? So it's a OS. System is ready with OS, right? Now system is ready here. Now this OS is responsible to take any request here. So double click on some Eclipse. OS is responsible to launch Eclipse. So double click on WhatsApp. So OS is responsible. Every request, for every request, OS is responsible. OS is responsible in SCP. Like this, when you double click on this, for all of these things, OS is responsible. OS is responsible for every request. OS is responsible. Okay, right? Suppose learning C language. First of all, you have to install C software. Suppose learning C++, that should be installed. Java, learning Java, Java you have to install. Okay, suppose Hadoop, Hadoop learning, Hadoop. Suppose database using it, the database you have to install. Suppose learning Python, the Python you have to install. Yes, all these are called application softwares. All these are application softwares. All these are application softwares. All these are application software. Application software. All these are application software. Okay, like C, C++, Java, and Hadoop. All this. One second. Yes, all these are application softwares. Okay, C, C++, Java, Hadoop, database, Python, and all these are application softwares. All the application softwares running on top of OS. On top of OS, all are running. So OS it's giving platform. Just OS it's giving platform. So OS giving platform. On top of OS, all are running. On top of OS only, all are running. Like C, C++, Java, Hadoop, all are running on top of OS. It's giving platform. So here OS is acting like a platform. So what is OS means? It's a platform. Simply our answer. Yes, OS is a platform. Yes, it is a. It's a platform. You say yes, it's a platform. It's a platform. It's a platform. OS is a platform. Yes, where we can run all the application softwares, all the application softwares, all the application softwares, all the application software. Okay, so OS is a platform. What is OS? It's a platform. OS is a platform. OS is like a platform. It's a platform. It's a platform where we can run all the application software. Where we can run all the application software. It's a platform. OS is a platform. So acting like a platform. So OS is a platform where we can run all the application software. Yes, not only platform here, not only platform here. Suppose C program generating some output or Java program generating some output. So output of all the programs simply delivered to OS first of all. First of all, delivered to OS. After delivered to OS here, next finally transport to output device. Okay. So here output of all the programs. Okay. Output of all the programs transferred to output device through the OS. Through the OS. So first of all, output goes to OS to output device. Suppose reading from the keyboard, input device. That input device data goes to OS. So OS to your programs. So between application software and hardware, there is a like a mediator. So this is acting like a mediator. OS is acting like a mediator. OS is acting like a mediator. It's acting like a mediator. So OS is acting like a mediator. Okay. Yes. Yes. OS is acting like a mediator between application software and hardware components. So means you can say interface. It's an interface. So OS is an interface between application software and hardware components. So next point. So it is an interface. Yes, it is an interface. It's an interface. It's an interface. It's an interface between. It's an interface between. Yes, this is application software. It's interface between application software and hardware components. And hardware. See, application software between application software and hardware. Here this is a OS. So it's interface. It's an interface application software and hardware components and hardware components and hardware components. So what is OS means? Simple answer. What is OS means? Simple answer. It's a platform. So OS is a platform. OS is a platform. Okay. OS is a platform. Okay. Once some guy is asking for link is missing. Just a minute. Just a minute. Just a minute. Yes. So it's an interface. So OS it's an interface. It's an interface between application software and hardware components. Right. So here OS is a platform. Yes, here Java is an independent platform, right? See here. Yes, first one. Independent platform. Platform means OS. So how this OS is working? Let us see about this OS here. It's a platform. So OS is a platform where we can run all the application softwares. Next is an interface between application software and hardware components. Okay. Fine. Next. See here to communicate between application software and hardware. Yes, OS internally using libraries. Internally using some libraries. There are some libraries. Okay, it's libraries. So every ways this is very important point for us. Java point of view, this is very important. Libraries. So every ways has its own library to communicate between application software and hardware components. Libraries. So what is library here? Library is a collection of functions. Library is a collection of functions. Library is a collection of functions. Library contains all the functions here. Library contains all the functions. It's a collection of functions. Okay, means C language functions. Yes. Here operating systems developed in C language, like Windows in C language, Linux in C language, Unix in C language. Almost applications were developed in C language. All are developed in C language functions. These are C language functions. These are C language functions. Okay, C language functions. Okay. Yes, C language functions. C language functions. So C language functions. It's a collection of functions. It's a collection of functions. So ways using library to communicate between application software and hardware components. So every ways. See here, every ways has its own libraries. Every ways adds one. Yes, one second. Its own libraries. Yes, library. Yes, every ways has its own libraries to communicate. Yes, to communicate between application software and hardware components. Yes, ways using library. So internally OS using library through it can communicate. 1 second, let me close this WhatsApp. Meeting disturbance. Yes. So every OS has its own library to communicate between application software and hardware components. Okay. See here what happens here. Before going to run any program, first of all, it has to link with OS library. Maybe C program running, maybe Java program running, maybe yes, C++ or Python, any program. Yes, all of the programs, first of all, these things has to link with OS library. Of linking to the library communicates with the hardware components. Every program has to link. This is very, very important for Java. For Java concepts, very important here. So this is application software like C or C++, Java, yes, Hadoop, database, Python, all the programs. Every program, yes, every program, first of all, linking with OS library. So first of all, just linking with OS library, of linking with OS library, using libraries, it can communicate with hardware components. That's it here. Okay, so every program has to link with OS library. So every program has to link with OS library to communicate with hardware components. Okay, that linking may be statically linking or dynamically linking. Statically linking or dynamically linking. Suppose if it is C and C++ static link, C and C++ static link. Suppose Java Python is dynamic link. Java and Python with dynamic link. Okay, yes, dynamic linking here. Okay, Java and Python may be dynamic linking. Yes, the topic we'll discuss next, independent platform. At that time I'll explain how Java is dynamically linking to OS library, how C program yes, statically linking to OS library. That the topic as we'll discuss. Yes, very important for us. Okay, yes. So it's very important for us. So every program has to link with OS library before going to run it. Java program running. For this purpose, first of all, it has to link with OS library. Then, yes, running this. Then executing, getting output here. C program link with OS library. C like this. Every application software, every program has to. Every program has to link with OS library. Every program has to link with OS library to communicate with hardware components. Okay, before going to run it here, every program, you maybe C program, maybe Java, maybe Python, something like this. All the programs, every program has to link with OS library. Okay, OS library before going to before going to run it here. Before going to run here. So first linking with OS library, then program run here. Okay, maybe static linking, dynamic linking. Yet the topic I'll explain practically. In C language is statically linking. Java is a dynamic linking. Python also dynamic linking. Yes, practically I'll show how C program linking statically, how Java and Python linking dynamically. So static link and dynamic link practically I'll show you here. So this is just idea about OS. Enough for us here. Okay, enough for us. So what is OS? What is OS means? Simply it's a platform. It's a platform. Yes, on top of it, we can run all the application softwares. OS acting like a platform. On top of it, everything can be run here. Everything can run here. Okay. It's a platform where we can run all the application softwares. Next, it's an interface. It's an interface between application software and hardware components. Next, remember this point, fourth point here. Fourth point. Every program has to link. Every program has to link with OS library before going to run it. Yes, first of all, linking, then communicates with hardware components. That's it. So this is about OS. Okay, fine. Let us go to document here. Here's our Java document. So this is our Java document. Yes, yeah, this second I guess updated. Okay, so this is our Java document. See, so this is today topic. Introduction to software. Software is a collection of programs. Same that point explained here. Software basically two categories: system software, next application software. System software, it interacts with hardware components. Example, device drivers and operating systems. Application software, this is for the purpose of application development. Example, these things here. C, C++, Java, and all this here. Okay. Except OS. Except OS. Except OS, all our application softwares. Except OS, all our application softwares. Okay. Fine. Yes, device driver, they are to run the devices. That is not required for us. Next OS. Same point. See. Yes, every program links with OS library before we start execution here. Same the points. What are the points we discussed? It's there in document here. So running notes is not necessary here. You guys not required to write any running notes. Running notes is not necessary here. So everything very clearly prepared. Okay. Java comes under application software. Okay, our topic is now application software. Now let us move to application software. Moving to application software. See, application software basically two categories. There is a front end, back end here. Front end, back end. So what is front end? What is back end here? Front end, back end here. So what is front end? For example, here, this is front end. This is front end. This is front end. This is front end. Here, filling all the info is a registration form, right? Registration for filling all the information and register, right? This is called as front end. Front end registration form, like a Gmail ID. Suppose if you're creating Gmail ID, your details has to submit. Yes, any registration of account, registering your account with maybe Gmail ID, maybe Facebook, maybe yes, Amazon, whatever it is here. So you have to register first of all. Okay, this is called as front end here. So this front end, yes, user interface, GUI, user interface, graphical user interface, front end. This is called as front end here. So front end collecting data from you, right? This is collecting data from you. After collecting data, storing some location, that location is called as package. So once your information is stored somewhere here, Durgasoft, they can take your information, they can track it. Okay, they can go for the follow-up here. Okay, right? So this is called as front end here. So front end interact with end users. We are the end users of this application. So go to training application we are using. We are the end users. Okay. So this is called as front end here. Front end interact with the end users. Front end interact with end users. Back end is to store data, to store and maintain data. Okay. Same thing explain document as front end. Front end. See front end. These are interacts with end users. It collects data from end users and stores in the back end here. So collecting data from end users, it collects front end collecting data. Back end is to store and maintain data. Back end is to store and maintain data. So back end example databases and files. In database storing data, in file storing data. Okay. So front end examples language and packages. Okay. So what is Java? Java is a language. So Java comes under what? Front end here. Now let us move to front end. In front end, language and packages. Package is ready-made and ready to use. Like ERP packages, like SAP ERP, Oracle ERP, MS Office, Tally accounting package, they are ready-made and ready to use. No programming. Without writing any programming, you can use package. No programming in this language means everything is should write the coding here. In this coding, right? Yes, Java is a language. Now let us move to languages. So our topic is now languages. Okay. Yes, about languages. About languages. Okay. Yes, language. What is language? See, you speaking many languages, right? We are speaking many languages. Why is speaking many languages? What's the reason here? What's the purpose? Communication purpose. Just it's a media of communication. Language is a media of communication. Language is a media of communication between two living things. Language is a media of communication between two living things, maybe two persons or two animals, maybe two trees. So everyone has their own language. Fine. Now let us come to software. Let us come to software. In software here language, software languages. In software we are understanding some language. For example here, for example, C program. Let us take some C program. Suppose C program. Suppose this is some C program. Yes, it's like English language, right? C program. It's like English language, looking like English language. Suppose let us take some Java program. Suppose some Java program. Suppose this is some Java program. Java programmer. These are like English language. These are like English language. Okay. Suppose one more example Python. For example, Python example. Python. Python. Yes, Python. Python course. So these are like English language. So this is user understandable language. This English language is a user understandable language called as high level language. It's a high level language. Next, another one, computer understandable. There are two things here: user understandable and computer understandable. Means our understandable. We are understanding this language. This is our language, right? Computer understand different language. So what is computer understandable language here? It's a binary code. Computer understandable language. Binary code. Computer understandable language. Binary code. System understandable language. Binary codes. Like a zero response format. It's a system understandable language. Okay. So languages are three categories. First one, a system understandable called as low level languages. Yes, low level. Yes, low level. Yes, low level languages. Low level languages. Low level languages. Okay, low level languages. First one, low level languages. Low level. Yes, languages. Low level languages. Next, high level language. Second one, high level language. Low level. Yes, next, high level language. Low level and high level language. Low level and high level language. Again, low level and high level languages. Low level and high level language. Okay, languages. Basically two categories here. Low level languages. Next, the high level language. So what is low level language? Low level language it is a system understandable language. It is a system understandable language. It's a system understandable language. It is system understandable language. It's a system understandable language here. System understandable language. Low level language. It is a system understandable language. Okay, it is a system understandable language. It is in the form of binary codes. It is in the form of binary codes. Binary codes. Binary codes. Binary code is like the zero response format here. Zero response format. Zero response format. It's a binary code. Okay, it is called as machine language. Yes, it is called as machine language. It's called as machine language. It is called as machine language. Called as machine language. It's a machine language. Called as machine language. Yes, it is called as machine language. Okay, it is called as machine language here. Low level language. It's a system understandable language. It's a system understandable language. It's a system understandable language. Understandable language. It is in the form of binary code, like a zero response format. It is called as machine language. It is called as machine language. So this is low level language, right? Okay. Next, high level language. Yes, it's a user understandable language. It is a user. Yes, user understandable language. It's a user understandable language. It's a user understandable language. Okay. Yes. 1 second. Yes. It's a user understandable language. It's a user understandable language. It is like English language. It is like English language. Like English. Very easy to understand. Very easy to understand. Very easy to understand. Very easy to understand. Very easy to understand here. Very easy to understand. It's like English language. Very easy to understand. It's like English. Very easy to understand. C. This is C program. High level language. C program. High level language. Yes, next Java program. It's a high level language. Next Python script. It's a high level language. These are high level language. Like English language. Very easy to understand. So these are called as high level language. Low level and high level language. Low level and high level language. Okay. So in software here languages. Basically two categories. One is user understandable language, another is computer understandable language. User understandable and system understandable. Yes, system understandable called as low level language. Low level language. User understandable called as high level language. Okay, low level and high level. Low level, it's a system understandable language. It is in the form of binary code. It is in the form of binary code. It is called as machine language. It's a machine language. Machine language. High level language. It's a user understandable language. It is like English language, very easy to understand. Okay, fine. Now here, some question here, some question. So this is high level language, right? User understandable English language. This is like English language. System can't understand this. This high level language, this program has to convert into system understandable language. Maybe Java program, yes, maybe C program. These programs have to convert into binary codes. Who will convert this? Suppose Python scripting. Yes, all the programs. This high level language like English language. This English language has to convert into binary codes. Who will convert it? Yes, any idea? So which one will convert from high level language to binary codes? System understandable language. Which one will convert? Which one will convert from high level language to binary codes? Yes, guys, come on. Which one will convert? Good, good. Compiler. Next, one more thing. Compiler. Next, one more thing is there. Compiler. Next, one more. One more. Interpreter. Interpreters and compilers. Okay. So you are converting from, yes, high level language to low level language for this interpreters. Yep, this is very, very important topic for us. Yes, interpreter or compiler. Either interpreter or compiler. Interpreter or compiler converts from, yes, converts from this high level language. Converts from high level language to this low level language, initial language. Low level language, but English language to binary codes. Okay, so interpreter or compiler, so either interpreter or compiler converts from high level languages to low level language. High level language to low level language means like English language. Yes, Java, it's English language that has to convert a system understandable language. Yes, compiler or interpreter. Either compiler or interpreter converts. Either interpreter or compiler converts from high level language to low level language. Okay. Yes, what is interpreter? What is compiler? Java based on what? Is it interpreter based or compiler based? Let us see this. After finishing this topic, we'll go to that independent of platform and portable that features. To understand that Java features here, you must have this knowledge here. Interpreter and compiler. Yes. Anyone idea? Yes. Anyone idea about interpreter and compiler? Maybe already having some C knowledge. Already somebody have maybe C knowledge. That guys. Yes. Any idea? Interpreter versus compiler. What is interpreter? What is compiler? At least one difference. Difference between interpreter and compiler. What's the difference between interpreter and compiler? What's the difference? Any idea? What's the difference between interpreter and compiler? Let us see. Let me explain. So first of all, let us take interpreter. So what is interpreter? How it's working? For this interpreter, let us take Python. Python is an interpreter based language. So Python source codes. So Python source codes. Yes, maybe test.py. That Python script file. Python source codes. Okay. Yes. Let us go to Python. D drive. Yes, mn Python folder. Yes, need some test.py files. Let us go to this location. CMD. Command prompt. Yes. D drive. D colon that will take to D drive. D here some output here. So mn Python. This is CD change of directory. Yes, mn yes, Python. Yes, changed to CLS clear skin. Yes, DR. Now here outputs. The output is like this. Now test.py Python script. Python script. Let us see this. Yes, notepad. Test.py. Just open this. Now this Python script. Yes, first statement A equal 10, B equal 20, C equal to A plus B. So addition, displaying addition value. C equal to A minus B, subtraction. C equal to A into B, then multiplication. So top to bottom, executing all the statements, generating outputs. Now let us run this one here, Python script. So Python script here. Yes, Python script. Yes, directly can run it. Python, directly running. Suppose if it is C program, first of all you have to compile it, right? C language, first of all you have to compile. After compilation, if no errors, you have to run it. That is C language. But Python, no errors checking, nothing, directly running program. In C language, first of all, you have to check for errors. Compiling program. Yes, if no errors, then running your program. But in Python, directly here. No errors checking, directly running here. See this. Program. Yes, addition equal 30, subtraction equal to -10, multiplication equal to 200. Okay, see this program executed directly here without checking for any errors. Okay, suppose for example some errors. Let's say some errors. Suppose some errors, some mistakes. Suppose here comma missing here. Suppose here double quotation missing. Suppose here bracket missing. What happens here? Save, and now run it. Here directly running here. No errors checking here. No errors checking. Suppose C language, first of all, you have to check for errors. But here, no errors checking here. Direct running. See this. See. Yes, seventh line error. So, seventh line error. So, once error comes, simply stopped here. Yes, he is not showing other errors. Only first error. Only first error. First error. Only first error. That seventh line error, right? So, once error coming, simply stopping here. So, seventh line error. No, correct this error. Only one error showing here. Seventh line error. Yes, correction is done. After that, now submit again. Now 11th line error. Means any error comes, simply stopping here. Any error comes, stopping. That means it shows only one error. Only one error. Suppose if it's C program compilation top to bottom, right? That also will discuss. C program compilation also will discuss. So this statement for correction of this error. Okay. Now run again here. Again, yes, only one error. Again error. One more error. 79 error. One more error, right? So this one showing only one error. Only one error. Not all the errors. That means what happens here? Checking first statement. If it is correct, next statement correct, next statement, next suppose something wrong, simply stopping here. Okay. So what happens here? It's the interpreter. Interpreter checking syntax of first statement. First statement correct. Once correct here, it executes. That means memory allocating for a storing 10. Next, this also correct. Memory allocating for the storing 20. This also correct. C equal to A plus B. C equal to A plus B. So performing and ascend C. Next print here, suppose error here stopping. Suppose any error comes, simply stopping here. If no error, this statement also executes. This statement like this. So here, line by line. So this working is line by line. Okay. See here how interpreter is working. Let me explain clearly. Suppose your Python script statements here. Python script. Yes. Suppose first statement. Yes. Next statement. There are some statements. Python script statements here. Some statements. There are some statements. There are some statements. There are some statements. There are some statements. Yes, how Python interpreter is working here. So you can first of all checking for the first statements. Suppose the first statement is correct. First statement is correct here. Immediate that converts into binary code. The statement converts into binary codes. Yes, once zeros once format. Okay. Yes, after converting into binary code here. Yes, interpreter checking for the first statement. Suppose first statement is correct. First statement is correct here. Immediately converts into binary code and given to processor. Just given to processor. Just given to processor. Just submitted to processor. Okay, given to processor. So processor taking the binary code here and generating output file here. So generating outputs. Okay. Yes. Next after this, checking for next statements. Suppose next statement also correct. Here. Same. Next statement also correct. Immediately converts to binary code here and submit to processor generating output. So line by line checking first line correct and executed. Second line checking here correct executed here. Okay. Next line. Suppose something wrong, simply stops. Something wrong stops here. Any error comes, simply stops. It shows only one error. Any error comes, simply stopping here. It won't check for next coming errors. Yes, any error, simply stopping there. So first line checking. If it is correct, then execution immediately. Next line correct, immediately execution. Any error, simply stopping. So this is about interpreter. Okay. Yes, how compile is working. How compile is working. Let us take C program for the compiler. For compiler, yes, Linux. Let me start Linux. Yes. Yes, how compile is working. Let us see about compilation. For the same thing, how compile is working. Yes, let us see about compiler. Yes, compiler. Okay, suppose test.c program. Test.c program. How compile is working here? See, first the compiler checking for the first statement. Some first statement correct. 1 second. Okay. So first statement correct. Even first statement is correct. It won't convert into binary code immediately. See, in case of interpreter, immediately conversion then execution. Line by line. Converting then execution. Conversion then execution. Line by line. But compile is like this. Compile is not like that here. Checking for first statements. If first statement is correct, then checking for next statement also. Next statements. Suppose next statement also correct, checking for next one. Suppose something wrong here, error yet some line. After that, checking for next line also. Checking for next line. Checking for top to bottom. Yes, compiler checks all the statements from top to bottom and shows all the errors. All the errors. Yes, compiler shows all the errors. Checking for all this. Compiler shows all the errors. Top to bottom. Okay. So compiler checks whole program from top to bottom and shows all the errors. In case of interpreter, any error comes in the stops. Only one error. Interpreter shows only one error, but compiler shows all the errors. All the errors. All the errors. Okay. Yes. Next, you have to correct all the errors. You have to correct. First, you compile, checking for errors. Check compilation means just checking for errors here. Suppose next time, yes, after correction, next time no error. Next time no error. Next time no error. Then what happens here? Next time if no error, what happens? If no errors in the program, compiler checks whole program from top to bottom. If no errors, what happens? Let us see. 1 second. Let me show that example. ls yes cd yes okay C project. Move all this all are remote here. Doesn't work in directory. Yes, you guys, you don't worry about Linux commands. Our topic is about compiler. Just to try to understand about compiler. Don't think about Linux files. Okay. Yes, ls no files, gedit like notepad, Windows notepad. Linux is gedit. Gedit test.c program. Okay, test.c. Yes, it's a notepad. Gedit means like a notepad, Windows notepad. Yes, open here. Hash. Yes, includes. Hash includes std io.h. Hash include std io.h. White main function. Yes, starting, ending. Okay. Same program. Same addition, subtraction, multiplication of two numbers. Same like a Python script. So a equal 10 here. So next int a equal 10. Yes, next. Yes, into b is equal to 20. Into b equal 20. Right? Next int c declares. After that, no. C equal to a plus b. C equal to a plus b. Printf, printf, printf. Yes, addition. Yes, addition. Addition equal to yes, optionally slash and take to next line here. Get displaying C value. Okay, so addition. Next subtraction. Next multiplication. C equal to a plus b. C equal to a minus b. Next subtraction. Subtraction. Subtraction equal to displaying C value. Next C equal to a into b. Multiplication. So multiplication. So multiplication. Yes, multiplication equal to so displaying C value. So this is our C program. Of writing C program, what is next step? Of writing C program, so next step. CLS the test.c. Next, you have to compile GCC -c test.c compilation. Yes, compile, no errors, no errors, no errors. Not generate one test.o file. Okay. Yes, now here. Now we should create exe file for this. -o. Yes, suppose exe name is project exe test.o. Okay. Yes. So project exe file created. That exe generated. Okay. That exe file created. Now run this exe file /project exe. Yes. Addition, subtraction, multiplication. So what's happened here? In case of Python, directly running that script, right? Directly running script, source code, this source code. Yes, our program called a source code. Test.py source code. The source code executed directly. But in case of C language, what happens here? First of all, it converts in exe file, running that exe file. Okay. See this exe file, GCC-o. This exe file generating. At the time of generating exe file, this exe file linking with OS library. It's a static linking. Yet the topic also will discuss. That is very, very important for us. Exe file, about exe file we should discuss. This exe file at the time of generating exe file, it links with OS library. After linking with OS library, then at runtime using that OS library to communicate with hardware components. See, previously we discussed one point here. So every program has to link with OS library. See, every program has to link with OS library before going to start execution, before going to run it, right? Run it. Yes, if it is C language here, the project exe file at the time of generation of exe file, that exe file links with OS library. After linking with OS library, then running at runtime using that library here. That is called static linking. Yes, 1 second. The topic we'll discuss next. Wait. That exe file dot plus the references. That time we'll discuss. Now, our topic is compiler topic. Compiler topic, right? That exe file created. Let us check that exe file. gedit project exe file. Let us open that exe file. That exe file contains what? Binary code. Exe file contains binary code. It's opening. It will take a little bit time because of yes, the exe file binary code. Julius one's format. It's a system understandable language. Julius one's format. It's a system understandable language. It's exe file. This is exe file. It's exe file. Binary code. Binary code exe file. Right? It's a system understandable language. Okay. So what is happening here? Simply generating one exe file. After generating exe file, that exe file executing here. So compiler checking all the errors from top to bottom. If no errors, generating one exe file, that exe file executes. That's it here. Okay. Now what happens here? Yes, compiler checking all the errors from top to bottom. After checking all the errors here, if no errors here, then yes, it generates another result file. It generates one more file called as exe file. That project exe file generates it. That exe file submitted to processor. So finally execution giving output. At a time executes, right? At a time. So that exe file submitted to processor here. So the statements, every statement converts into binary codes. Julius one's formats. Top to bottom, all the statements. Compiler checking all the errors from top to bottom. Checking every line from top to bottom. Every line from top to bottom. Compiler checking every line from top to bottom. If no errors, generating yes exe file. That whole code converts into binary format right to another file called as exe file. So compiler here generating exe file. See, in case of interpreter, no exe file, line by line execution. This is main difference. Main difference between interpreter and compiler, exe file. Exe file is a main difference. Compiler generates exe file. Interpreter does not generate exe file. These are main difference here. Okay. See, one more thing here. One more. Suppose 1 second. Remove start.go file. Remove p star project. Deleted test.c. gedit test.c. Suppose there are some mistakes. Suppose here semicolon missing. Suppose equal something missing here. Suppose here double quotation missing. Okay, suppose here this semicolon missing here. Suppose here this double quote missing. Suppose here comma missing. Save. And now let us compile this one. Let us compile this. GCC -c test.c, right? Test.c. See this, all the errors top to bottom. See, in case of interpreter Python, any error comes, simply stopping. But here shows all the errors. 7th line error, 11th line error, 13th line error, 17th line error, 22 line. Okay, the all lines from top to bottom. Compiler checks complete program top to bottom. Compiler checks whole program from top to bottom and shows all the errors. Interpreter is only one error. Any error comes, interpreter stops. But compiler is not like that here. Compiler checking whole program from top to bottom and shows all the errors. And shows all the errors. Now let us correct all the errors here. We should correct all the errors. Correction of errors. Suppose semicolon placing here. Okay. Suppose let us correct this error. This one. After that, now recompile again here. Recompilation. GCC -c. Yes, again errors. Again errors. Now 11th line error. The 7th line error removed. 11th line error, right? 17th line, 15th line errors like this. No. 11th line error. See line number 7. Yes, 11th line. This is 11th line error. So this is equal to. Next year, semicolon missing. Okay. Yes, next year, comma missing. So checking all the errors. After checking errors here, yes, GCC -c test.c. Yes, still errors. Huh? Okay. Yes, 13th line error, 15th line error, yes, still errors. Okay. 13th line, 4, 10, 10. This is. Yeah, this is double quotation missing. 13th line, this error here. Line number 13 here. At the bottom, you can select line number 13 error. Okay. Yes, next. Yes. Yes, after let us compile this. Yes, no error. S.o file generated. Okay, GCC -o for the TXE file. For the TXE file, the TXE name can be anyone. The result TXE name can be anyone. S.o. Yes, for the TXE file generated. What happens here? How the TXE generates? At the time of generating EXE file, this is binary code for C program. Test.o, it's a binary code for C program. Binary code for C program. Next, binary code for C library. std input data set file included. See in program here. See in program. std input data set file included. For this set file, this is a binary code. This set file also having some binary code. So this set file binary code. Next, your program binary code. Plus OS library binary code. OS is also having some library. That library also C language functions. Okay. So at the time of creating exe file here, your program binary code plus std input data set file binary code and OS library binary code. By linking these three, generating exe file. That is exe file. So what is exe file? Exe file contains what? Binary code of C program. Next, binary code of C library. Binary code of OS library. Suppose C++ exe file. C++ exe file contains what? C++ program binary code, C++ library, and OS library. That's it here. If it is Linux OS, Linux library. If it is Windows, Windows library. Yeah, that point also we'll discuss. Independent of platform. That time we'll discuss this point again here. Okay. So our topic is interpreter and compiler topic. Interpreter and compiler. So difference between interpreter and compiler. Okay. Let us see all the points first. Let us see points first. Difference between interpreter and compiler. Interpreter versus compiler. Let us see points first. Yes, let us see one by one. So interpreter and compiler. What's the difference here? Yes, interpreter and compiler. Interpreter and compiler. Interpreter and compiler. Interpreter and compiler. What's the difference between these two? Interpreter and compiler. So first interpreter. First difference. Interpreter checks the code. Yes, interpreter checks the code. It checks the code. It checks the code. It checks the code line by line, not complete program. Line by line, line by line. Only one line checking. If it is correct, executes. Next line checking. It's correct, immediately executes. Not all the lines from top to bottom, only one line checking. At a time, only one line checking, immediately execution. Next line checking, then execution. Next line, something wrong, stops. Okay. Yes, what is compiler here? So compiler, yes, whole program, it checks whole program. Compiler, yes, it checks whole program. Yes, it checks whole program, yes, whole program from top to bottom, from top to bottom, whole program from top to bottom. Okay. Next, so this is checking. Next, output also line by line. First line correct, immediately giving output. Next line correct, immediately output here. Something wrong, stop here. But in case of compiler, what happens here? Yes, output at a time, generating one exe file, that exe file executing at a time. So at a time giving output here. Okay. So you can output too. So output is line by line. Output also line by line. Output also line by line. Means what here? So this whole program at a time output. It's at a time output here. That exe file executing here. So at a time giving output. Okay. Yes, next. 1 second. Let me have some water. Next difference here. Yes, interpreter. It shows only one error. It shows only one error. Any error comes, interpreter stops. Means it shows only one error. Only one error. Compiler, all the errors. All the errors from top to bottom. All the errors from top to bottom. From top to bottom. All the errors from top to bottom. Right? So next difference here. Interpreter, no exe file concept. Interpreter does not generate exe file. Yes, it does not. It does not generate. It does not generate exe file. It does not generate exe file. Yes, company generates exe file. It generates exe file. Generates exe file. It generates exe file. Right? So in case of interpreter, Python, yes, interpreter based, directly source code executing. Python is interpreter based. Directly source code executing here. Directly source code executing. Suppose one more example here. One more interpreter based. Yes, advanced Java. HTML. HTML code also interpreter based. HTML also interpreter based. HTML. It's a browser understandable language. It's a browser understandable language. Yes, for HTML, browser is the interpreter. Browser is the interpreter here. Yes, in HTML also directly running this code here. Double click and run it. It's opened. It's interpreter based line, directly executing, no compilation, nothing, no checking errors, directly running program. With the source code executing directly here. Yes, interpreter based source code executes. So the source code means your program source code. The source code executes directly here. Source code executes directly. Source code executes directly. Okay. Compile exe file executes. So first of all, generating one exe file. Generating exe, that exe file executes. Here exe file executes. Okay. So interpreter, source code executing, compiler, exe file executing. Right? Okay. Yes. See here, interpreter based language. These all are scripting language. These are scripting language. These all are scripting language here. Interpreter based language, scripting language here. Called a scripting language. Okay. Yes, all interpreter based languages are scripting languages. Compiler based called as programming language. Yes, programming language. They are programming language. Okay. So again, interpreter based called as scripting language. Yes. Compiler based called as programming languages. Okay. Fine. Scripting language examples. What are examples of scripting language? Python. Just now we have discussed. Python is the best example. HTML is scripting language. Linux is shell scripting. So Linux shell scripting concept. Yes. Some test.sh, some script test.gedit, some test.sh, some script. This is some script. Okay. Script. Here the script. No error checking, directly executing the script. Dash means like a Python. Python test.py like that, bash test.sh. Enter first number, enter second number. Yes, now which one you want? Addition, subtraction, multiplication like this. 1. Yes, addition equal 30. Okay, first number 10, second number 20 here. Suppose 2 for subtraction. The program executing directly here. Okay, yes, next 10, 20, third one. Yes, multiplication. Okay, so first number 10, second number 20. So by mistake, not of 20, maybe 5. Wrong choice. The script executing directly here. So Python script. So the Python script. No errors, checking, nothing here. That executing directly. That executing directly here. The Python script executing directly here. Okay. Yes, it won't check for any errors. Directly execution here. Direct execution of this. Okay. So script executes directly here. Source code executes directly here. Okay. So Python, HTML, shell script executing directly here. Script executing directly. Okay, shell. Next, one more example, PHP scripting. Next, yes, Perl scripting, all scripting language. Okay, next, JavaScript. JavaScript is not a Java. JavaScript is different, Java is different. JavaScript is a browser understandable language. Java is a JVM understandable language. Okay, yes, compare example, compare with examples. C language, C++, .NET. Right? Okay. Now it's a surprising thing. Very Java. Simply talking about Python, C and C++, Java comes or what? That I have not mentioned. Yes, you guys maybe, yes, Java comes under what? Maybe thinking about it. Java, is it compiler based or interpreter based? So what is Java? Is it compiler based or interpreter based? Yes, I'll explain how Java program is working. After that, you decide it. I will explain how Java program working here. Is it compiler based or interpreter based? You have to decide. First, let me explain. Based on that, you decide it. Okay? Yes. So next point here. See. Yes, interpreter based. Simple here. Interpreter based language. Interpreter based language. Yes, base language don't have exe file. Don't have exe file. Interpreter based language don't have exe file. For Python, no exe file. Directly script executing. HTML no exe file. Shell scripting no exe file. PHP file, all these in no exe files. Directly script executes. So here everything is exe file. Here everything is exe file. Everything is in exe file here. Everything is an exe file. Is an exe file. Okay. So any language which is interpreter based don't have exe file. Any language which is interpreter based language don't have exe file. Interpreter based language don't have the exe file concept. That's it. Now let us come to Java. What is Java here? Java. Yes, is it compiler or interpreter based? Let me explain about Java. After that, you decide it. You decide it here. Okay. Yes. About Java. Yes. See, except Java, suppose other languages, except Java, other languages, except Java, other languages, maybe C or Python or C++. What happens here? First of all, source code means your program. First of all, source code simply converts into binary codes. Source code converts into binary codes. Source code converting into binary codes. See here, that's C program. Yes, C program. Source code converted into binary code exe file that executes. Next, even Python scripting also, the source code converting into binary for line by line conversion. Okay, both are converting binary code, but the way of working is different here. So here also binary code. Okay, interpreter based language or compiler based, any case, binary code required compulsory here. To run it, binary code required. But the way of working is different here. Way of working is different. So way of working is different. Okay. So here, except Java, yes, in other languages here, source code converts into binary codes. That binary code given to processor. Okay. Yes, processor generating outputs. Okay. Source code convert into binary codes. Yes, source code to binary codes. maybe interpreter, either interpreter, only one thing working here. Either interpreter working or compiler. Suppose if it is Python, interpreter converts source code to binary codes. C program, compiler converts source code to binary code. C++, compiler converts source code to binary code like this. Yes, HTML, browser. Browser is interpreter. Browser will convert source code to binary codes. Okay, that's a case of other line except Java. Yes, now let us come to Java. In Java, what happens in Java? What happens here? In Java, so first of all, these source code converted into byte codes. Yes, byte code introduced in Java. Okay, byte codes. Source code converts into byte code here. After that, byte code converts into binary codes given to processor, then getting output. So between source codes and binary code, they say byte code. Yes, intermediate codes. Why byte code introduced in Java? To make the Java as independent platform. Byte code main purpose is to make the Java as independent platform. To make the Java as independent platform, byte code was introduced. Yes, we'll discuss. What is byte code? How it is independent platform? We'll discuss. Okay. Source code converting into byte code to binary code, yes, given to processor, then generating outputs. Okay. Yes, who will convert source code to byte code here? For this compiler, for the Java compiler. So Java compiler. Java compiler, Java compiler. So Java compiler converts Java compiler source code to byte codes. Okay, Java compiler source code to byte code by the Java compiler. Next, byte code to binary codes. We'll do this here. Byte code to binary code. This is by the Java interpreter. Okay. So byte code to binary code by the Java interpreter here. Okay. See what happens here in Java. Yes, errors. See errors. First of all, errors checking by the compiler. Errors checking by the compiler. If no errors, generating one dot class file. Okay. Next, program execution, runtime, program execution, runtime by the interpreter, Okay, error checking by the compiler, runtime by the interpreter. Okay, so error checking, source code to byte code converting by the compiler. At runtime, byte code converting to binary code by the interpreter. So Java compiler interpreter both are involving this. Okay, see what happens in Java here. Suppose, for example, test.java is source code. Test.java is source code. For example, source code. It's a source code file. Test.java is source code file. This source code file given to Java compiler. Java compiler. After compilation, if no errors here, generating one tested dot class. It's a byte code. So byte code. Test.java converting to test.class. It's a byte code. Now this tested.class file, this byte code file, tested.class file. This tested.class file given to Java interpreter. Java interpreter. So taking the dot class here, generating binary codes. Just generating binary code, the binary code given to processor. Yes. So here interpreter taking tested.class file from dot class file, taking first statement, convert into binary code and given to processor. Generating outputs. Okay, generating output, right? Next, taking second statement, converts into binary code and given to processor. So line by line. Yes, runtime is line by line. Okay, here no exe file here. Okay, interpreter. So what happens here? Test.java source codes converting into byte code by the Java compiler. Yes, if no errors, generating one dot class file means byte code file. That byte code file is given to interpreter. Interpreter line by line converting into binary codes and given to processor, generating outputs. So runtime by the interpreter. Okay, errors checking by the compiler. Runtime by the interpreter. So errors checking by the compiler, runtime by the interpreter. Okay, runtime by the interpreter. So here for error checking purpose, compiler working. Yes, execution purpose, interpreter working. Now Java depends on what? Tell me. Java depends on what? Errors by the compiler. Okay. Yes, runtime converting into binary code by the interpreter. Suppose if it is C program, compiler will do everything here. Error checking and converting into binary code by the compiler. Python interpreter, error checking and converting into binary code by the interpreter. But when come to Java here, Java errors checking by the compiler, errors checking by the compiler, yes, converting into binary code by the interpreter. Okay, so Java depending on what here both. So Java, yes, there are two things involving a compiler as well as interpreter. So Java depends on Java depends on both. Java depends on both interpreter as well as compiler Java depending on both here. So Java is it compiler based or interpreter based? Maybe asking this question here. Java interpreter based or compiler based? Both. Errors checking by the compiler. If no errors, runtime by the interpreter. There are two things involving Java. Compiler, interpreter. There are two things involving Java. Errors by the compiler, runtime by the interpreter. There are two things. Java depends on both here. Java depends on both interpreter as well as yes, compiler. Java depending on both interpreter and compiler. Okay. Next, one more thing here. Yes. Now question, now as per my explanation, yes, is there any exe file concept in Java? Is there any exe file concept in Java? Question. Yes, question is there an exe file concept in Java? Is there any exe file concept in Java, or can we create exe file in Java? Yes, in this my explanation. Yes, anywhere observed about exe file? Yes, anywhere observed exe file? Test.java getting dot class file. The dot class file converting to binary code and immediately executing. Means is not generating in exe. No test.exe file. No exe file generating. Okay. Next, one more thing here. As per this point, last point. Interpreter based language don't have exe file. See, 1 second. See, any language, runtime is an interpreter based. Okay, any language runtime is an interpreter based. Don't have exe file concept. Don't have exe file simply here. Okay, any language runtime is an interpreter based. No exe file. No Java. Let us come to Java. If it is Java here, in case of Java here, Java language. See, Java language runtime is interpreter based. So runtime is interpreter based. So that's the reason no exe file. Don't have exe file concept in Java also here. Okay, Java language runtime is interpreter based. Java language runtime is an interpreter based. Since it's interpreter based, no exe file concept in Java. Here question: can we create exe file in Java? No exe file concept in Java. In Java, everything is dot class file. Everything is dot class file. Okay, dot class file is not exe file. Exe file is different. Dot class file is different here. The topic tomorrow we'll discuss. What's the difference between dot class exe file? Tomorrow topic I will explain here. Okay. Yes. 1 second. See, this is your document here. Document. Every topic very clearly explained here. Front end, back end, language, packages, low level, high level languages. See, generation of language tomorrow we'll discuss. Wait. Interpreter, compiler, the differences. All the 7 differences explained here. 7 differences. Okay, sorry, 9 differences. All the differences explained here. See, Java depends on both compiler as well as interpreter. Same points explained here. Yes, in Java, errors checking by the compiler. Yes, if no errors, generating dot class file. Dot class file is a bytecode file. Yes, Java runtime by the interpreter. Okay, see this. Source code given to Java compiler, generating bytecode file. Yeah, that is given to interpreter, generating binary codes. So next, generating output finally here. See this here. Source code to bytecode to binary code, run processor output, right? Source code to bytecode by the compiler, bytecode to binary code by the interpreter. So Java depends on both compiler as well as interpreter. Java runtime is interpreter based. Okay, any language runtime is interpreter based, no exe file concept here. Any language runtime is an interpreter based, no exe file. Since Java, yes, runtime is interpreter based, no exe file concept in Java, no exe file concept in Java. Can we create exe file in Java? No, there is no exe file concept in Java. Yes, in Java everything is a dot class file. Dot class file is not exe file. Dot class is not exe file. So what is dot class? What is ex? The differences. Difference between exe file and dot class. This topic tomorrow we'll discuss. Yes, tomorrow we'll be discussing about this independent platform. Tomorrow topic will enter in this one here. Tomorrow is finishing features. After that we'll go to Java installation. Next, right? How to write Java programming. The topics we'll discuss. Okay. Yeah, that's all for today. Yes, you understand, guys? Yes, understanding clearly. Any doubts? Hello. Are you understanding clearly all the topics? What I'm explaining? Are you understanding clearly? Are you feeling any fast? Yes, you don't worry, guys. Slowly I will explain. Slowly, each and every topic very clearly I will explain. Like a spoon feeding. Non-IT background guys also can understand very clearly. Even kids also can understand. Like that, very slowly, clearly I will explain it. Okay. Yeah, that's all for today. Yes, we'll continue tomorrow. Same 7:30 time. Thank you. Yes. Have a great night. See you tomorrow.